WTW 124 semester test 1 2022. Okay, so let's go look at question 1. Question 1 asks us, or tells us, let P be equal to this set and L be equal to this set. Determine all points of intersection of the line L and plane P. Okay, so they tell us P is a plane and L is a line. That's good to know. And then verify that all the points determined are elements of both L and P. Okay, so let's go think about this for a bit. First of all, for the plane, they give us a Cartesian equation, and for the line, they give us a vector equation. Okay, so we can't work with these two at the same time. So we have to choose to either take this Cartesian to vector or to take this vector to Cartesian. Okay, and further on in the course, you would see that it's easier to go to vector, okay, because Cartesian, it takes a while to work with. Okay, so let's take this to vector. Okay, so first of all, we need to get the normal of the plane P. So to get the normal, we just look at the coefficients in front of x, y, and z. So it's 1, 2, minus 3. That's the normal. Okay. And the vector equation for plane P would then be the following. We take the norm, we cross it with some vector on that plane, we're going to state that now, minus a coordinate we get on the plane. So we can choose now any coordinate that will work for this. If I take 5 plus 2 times 1 minus 3 times 1, I would actually get 4, because 5 plus 2 is 7. 7 minus 3 is then 4. So let's take any, I take 5, 1, 1, but you can choose any vector, and this will be equal to 0. That would be our vector equation for this plane. Perfect. So this x is just an element of the P. So that just maps out every single coordinate on that P. Okay. So now let x be an intersection of P and L if and only if. So now we say that this x is on P and on L if and only if what? If we just plug in the line vector equation into this x, we put in this vector in the place of x, then this would be true actually. So we take 1, 2, minus 3 dotted with 4 plus t, 4 plus 2t, and then minus 2 minus 3t, minus 5, 1, 1, which should be equal to 0. So now let's just simplify all of this, which will give us 4 plus t minus 5 is then just t minus 1. 4 plus 2t minus 1 is 2t plus 3. And the minus 2 minus 3t minus 1 is minus 3t minus 3. Everything equal to 0. So now there's a dot product, or just a dot between them. So this will produce a scalar. So 1 times the first component, which is just t minus 1. And then second times second, added to this one. So plus 4t plus 6. And then we multiply this with this, which will just give us 9t plus 9. Everything equal to 0. And now just solve for t. So t plus 4t is 5t plus 9t is 14t. Take all the constants to the other side, which will then become 1 minus 6 is minus 5, minus 9 is minus 14. So t is minus 1. So if we plug in this t into this line, then we actually get the intersection. So x is equal to 4 minus 1, 4 minus 2, minus 2 plus 6. Just make sure, oh no, minus 2 plus 3. Then this will be 3, 2, 1. And that's the point of intersection. So now let's go quickly verify that it is on plane P. Okay, so now let's go put in these values. So 3 plus 2 times 2 minus 3 times 1. So I just put our values into there. This will give us 3 plus 4, which is 7, minus 3, which is indeed 4. And that's correct. It should give us 4. And then verify on line L. Okay, so now, well, we literally just put in this minus 1 into this to actually get the vector out, which is 3, 2, 1. So for t minus 1, for some value t, this line will produce 3, 2, 1. So this is correct because it works for t is equal to minus 1. Now question 2, they give us these three vectors p, q, and r, and then 2.1 asks us to compute r minus p. Let's go write that down. So we want to compute, let's use green. So r minus p cross product with q minus p. Okay, so from this you can kind of feel or should remember that these are the same, so they would be basically the origin. Because remember, there's another way to calculate the norm of a plane or a normal of a plane. So yes, we could have just done this with the Cartesian equation, but there's also another way where you can kind of compute the n like this, q minus r. Okay, so if you have 3 points on a plane, then you can use this to calculate the normal. Okay, so we need 3 points. Okay, and one of them has to be basically the origin at which you take everything. Okay, so cool. Here we can kind of see P is that origin. So let's just substitute in all our values for our vectors. So R minus P. So R is 2, 1, 1 minus P cross product with Q minus P. So let's go simplify these vectors. So 2 minus 7 is minus 5. 2 minus 3 is minus 2. And 1 minus 1 is 0. That's our first vector. Cross product with another vector, which is 0 minus 7, which is minus 7. Minus 1 minus 3 is minus 4. 2 minus 1 is 1. Okay, so now there's a trick I use to calculate this. So if you know this trick, it will actually help you further on in the course as well to do cross products. It will come in with matrices because we are actually going to construct a matrix in the x, y, and z direction. Then you put in your vectors that you want to cross multiply. So minus 5, minus 2, 0, minus 7, minus 4, 1. Just be sure of the order. If it comes first, it goes at the top. So don't go and put this one at the bottom. Don't do that. So first one, top, bottom one at the bottom. Okay. Or the last one at the bottom. Okay, so now we're basically going to compute the determinant So again, if you have a method that works for you, please use that method. But if you know this method, it's going to make life much easier. And then you don't have to study a formula or anything. You can just know this method. So if you want to calculate the determinant, first cross out the first row and the first column. Okay. Then you say, okay, we crossed out the x component, and now we're going to see what we have left. So minus 2 times 1 minus 4 times 0. It's just minus 2. And now for the y component, we put a negative y component. And then we cross that out. So minus 5 times 1 minus 7 times 0. It's just minus 5. Okay, and then for the z, we do a plus z again. So it keeps alternating, plus, minus, plus. And then let's compute the z. So if we cross out the z part, then you get minus 5 times minus 4 minus 7 times minus 2. Okay, so minus 5 times minus 4 is 20 minus whatever we have here. So minus 7 times minus 2 is just 14. So 20 minus 14, that is 6. Great. So now in the x component, you have minus 2. In the y component, you have plus 5. And in the z component, you have 6. And that's exactly our answer. So if you cross these two vectors, remember you have to get a vector out. Cross brings out another vector. Dot, as in here, brings out a scalar. Okay, so this will be minus 2, 5, 6, directly from these components. Great, and that's more what they asked. Now 2.2 asks us to determine a Cartesian equation for the plane P through the point P, Q, and R. Explicitly verify the correctness of your Cartesian equation for P by showing that P, Q, R all satisfy the equation that you just determined. Okay, so let's go remember, we just use this formula is equal to 0, this formula, to get a vector equation for a plane. So now they basically are the same thing. They just give you 3 points. So now we can use this method. We got the normal, which we just basically computed if P is the origin point. Okay, that's exactly what we just did. So we already have the normal. So let's go write that down. So the normal for plane P, let's make it n is equal to minus 2, 5, 6. Minus 2, 5, 6. That's our normal. So they want the Cartesian equation for this. So the Cartesian equation for P. So how are we going to calculate this? Remember, we have a formula. We have that the normal times with this is equal to 0. We already have the normal dotted with x, and x is just x, y, z. It maps out all the coordinates on P minus just one of the coordinates on P. Remember, we want the plane to go through all of these 3 points. Okay, so let's just pick one. We can just literally pick any coordinate, just like the first question we did. You can pick any coordinate on that plane. So let's pick one of these. Let's choose the easier one because it has a 0 in. You can choose any one you want. You can choose this one, any coordinate. I'm just going to choose this because it has a 0. It makes the calculations a bit easier. So 0 minus 1, 2. So 0 minus 1, 2 is equal to 0. That's our plane vector equation. So now let's just simplify again. everything the same as the first question. So x minus 0, which is just x, y minus minus 1, which is plus 1, and then z minus 2. Now let's do the dot product. Remember, dot product produces a scalar. So minus 2 times x is minus 2x. 5 times this will give us 5y plus 5. And then 6 times this will give us 6z minus 12, which is 0. So minus 2x plus 5y plus 6z is equal to minus 5 plus 12, which is just 7. And that's actually our Cartesian equation. It has a x, it has a y, it has a z. Just like question 1 had this Cartesian equation. Okay, and equal to 7. And that's our Cartesian equation, but we haven't finished the question. They asked us to explicitly verify the correctness of your Cartesian equation for P by showing that P, Q, R all satisfy the equation that you determined. So let's just go quickly plug in all those values. So verify P on plane, on plane P. How do we do that? We just substitute this P, 731, into this. So 7, 3, 1, which is negative 14 plus 15 plus 6, which is 1 plus 6, which is 7. So P is actually on plane. Verify Q on plane P. And Q is just what? 0 minus 1, 2. So 0 minus 1, 2, which is minus 5 plus 12, which is 7. And then lastly, verify that our R is on plane P. Okay, so that will just be 2, 1, 1. 2, 1, 1. Minus 4 plus 5 plus 6, which is just minus, well, 1 plus 6, which is 7. And that works. Great. So there's our answer. Question 3. So consider the set P and Q. Okay. 3.1 asks us, determine any point P on the plane P that is not in Q. Show explicitly that the point P that you have determined satisfies the Cartesian equation for P but not for Q. Okay. So the thinking process here would be, okay, we want to find something on P, but it should not be on Q. Okay, so let's go find something where they are actually equal. Then we can just pick something else where they're not equal. Okay, so I will show you with this. So we have this equation for P, 3z is equal to minus 2. And we have this equation for Q, so x minus 3y plus 2z is minus 1. Cool, cool, cool. So now we can just kind of subtract this and check, because the x's will cancel. Minus 4y plus 3y is minus y. This will be plus z, and this would be minus 1. Okay, so this would satisfy the two equations, or the two planes would be equal if this happens. If you pick any x, because there's not an x present here, so we can pick any x, but if the y and z has a relationship of this, then the planes are equal. So let's just pick anything on this and then just check if it's not satisfying this. Okay, so remember, I can pick any x value. Let p be equal to let's say 1 or 0. Let's make it more easier. So I pick my x as 0. Okay, so it's 0 minus, let's pick, I don't know, 1, 2, 3. Let's pick 2. Okay, so let's pick our y as 2. And let's go quickly check what our z is. So 0 minus 4 times 2 plus 3 times z is minus 2. So minus 8 plus 3z is minus 2. So my 3z is equal to minus, no, 6, and z is then 2. So let's pick our p as this. Let's just check if my y and my z doesn't satisfy this relationship. So I picked my y as 2. I picked my z as 2. And are these equal to 1? No, they're not equal to 1. So I can actually pick this. Remember, this is for when they will actually be intersecting. Okay, so I don't want intersection now. I just want something that's on P, so it satisfies this one, but it does not satisfy this. That's the big thing. Okay, so let's just verify P is the element of this P. So 0 minus 4 times 2 plus 3 times 2 is minus 8 plus 6, which is minus 2. This works. Verify that P is not an element of Q. Okay, so 0 minus 3 times 2 plus 2 times 2. Okay, so this would be minus 6 plus 4, which is minus 2. And that's not equal to minus 1. So this doesn't work. So we are correct. P is indeed on the P, the plane P, but it's not on Q. Perfect. So now, determine all points of intersection of P and Q. Write your answer in set builder notation. Verify your answer explicitly by showing that all points in the set that you have determined satisfy both Cartesian equation P and Q. Okay, so we just determined something where they would be equal, regardless of the x we choose. Okay, so now let's go write these two equations so that we can actually get an idea of what our intersection would look like. Okay, so we have the main thing should be that minus y, this is written in one variable. So z is equal to minus 1 plus y. Y minus 1, yeah. So I just took this condition we calculated previously and I just said, okay, let's just get z alone. Cool. So now we have two equations. Plane P has an equation of x minus 4y plus 3z, and that's equal to minus 2. So now for this one, let's go substitute in our z. Okay, so x is equal to x minus 4y plus 3 times y minus 1. That's minus 2. So x minus 4y plus 3y minus 3 is minus 2. So x minus y is equal to 1. Okay, so now let's go write our y in terms of x. I'll show you why we do this now. So x minus 1 is y. And then for our second equation, let's use the fact that now z plus 1 is equal to y. I just changed our variable to be alone. So now for our other plane, that q plane, so x minus 3y plus 2z. So x minus 3y plus 2z is minus 1. Okay, let's go replace our y in this one. Okay, so here we replaced our z, but now I'm going to replace my y. So x minus 3 times z plus 1 plus 2z is minus 1. So x minus 3z minus 3 plus 2z is minus 1. X minus z is 2. This is our z. So now let's get z alone. So x minus 2 is z. Great. So now we have something to work with. Okay, so if we have these two equations, just watch out for this. Y is in terms of x, and z is in terms of x. That's what I wanted all along. That was my end goal, actually. Okay, so I have my one variable in terms of x and my other variable in terms of x. That makes our job a lot easier. So now let's say let x be equal to t for all t is element of R. So it's just a real number, any real number that can also work for x. Okay, then we have the following. We can actually write our answer then. So we have the set. With our vector, we set x equal to t. Our y component is right there. Remember, x is now t minus 1. Our z component is now here. Remember, x is t. So it's t minus 2. And this is the element of R3. Then this works for all t element of R. Okay, and they also ask us to verify that this works for all the planes. Okay, cool. So let's verify this. So verify for P. Okay, so let's substitute all these into our equations. So for P, our equation would be T minus 4 times our Y component plus 3 times our Z component. Let's go check what this gives us. T minus 4t plus 4 plus 3t minus 6. Okay, so as you can see, t minus 4t is minus 3 plus 3t. The t's will just cancel. And then we have 4 minus 6, and that's minus 2. So it works for this one, because this should equal to minus 2 if you plug in all the components. And now verify for the Q. So we have our x component minus 3 times our y component plus 2 times, yes, plus 2 times our z component. This will be equal to t minus 3t plus 6 plus 2t minus 4. Okay, so let's go check if this works. For this one, just want to make sure I got this one right. Cool, yeah. Okay, so again, let's go check at the t value. So t minus 3t. I did make a mistake. With the y component, I substituted in 2 minus 1, or 2 minus 2 instead of 2 minus 1. So this would just be plus 3. Okay, now it seems right. Cool. So t minus 3t is minus 2t plus the 2t. It will just cancel. And then 3 minus 4 is minus 1, which is correct because it has to satisfy minus 1. Okay, so question 4 starts with the more proof-based questions. So it takes a bit more not so obvious solutions, but still doable. So let's read the question. Let P, Q, and R be vectors in R3. Let theta be from 0 to pi denote the angle or the magnitude of the angle formed at vertex R in the triangle with vertices P, Q, and R. Use the definition of the norm and the definition of the magnitude of an angle to derive the following form of the cosine rule. Okay, so let's quickly draw this. They tell us theta is at R, so just remember that. If this is R, then theta is over here. Let's say this is P and this is Q. So yes, let's go start thinking about this. Keep in mind we're using the cosine rule later on, so let's work with this distance because it's across from theta. Okay, so we're going to work with this P minus Q first. And that's also what they started with. So it's a good sign. We're having the right concept. So now I'm going to do something that's not as obvious. I am going to rewrite this as P minus R minus Q minus R. Okay, so this is the part I was talking about that's not that obvious. Okay, so basically I have just added 0 to this. Okay, so why did I say this? This is minus R and this is plus R. Okay. My end goal, remember, is to use the cosine rule somewhere, but don't use the cosine rule here at the start. But kind of going a different route because we're first using the definition of a norm. So what does the norm tell us? It's this distance. It works with distances. Okay, so we can't just assume the cosine rule works instantly. Okay, so let's do this method first. Okay, so remember what this means. Because it's square rooted, I can just say, well, okay, it's the absolute of this times with itself. That's what square root means, right? Okay, so now I did that. Now I can actually just go and multiply everything out. So now I can say P minus R times P minus R minus 2 P minus R times Q minus R, and then plus Q minus R, Q minus R. Okay, so I just used the FOIL method, front, inner, well, front, outer, inner, and then last. Okay, so now let's go look at what this means. This I can just take back to P minus R minus 2. This I can't change. These are not the same. So I can't put them back in norm signs. Remember, absolute signs can go back to the norm squared. Just remember that. Just like I did here again. So Q minus R also squared. Okay, so but now we kind of have a problem. We have this term here that doesn't look quite what they have here. The rest is fine. We have P minus R squared, we have Q minus R squared, but this part we need to change. Okay, so this is where the angle theory comes in. Okay, so this was the first part, just to get this concept right. And the second part will be to use the magnitude of an angle formula. So that is again just it's going to be everything touching the theta angle, which is just P minus R dotted with Q minus R over the norm of this. Okay, norm of P minus R and Q minus R. Okay, so that's actually the formula you need to know. Okay, so knowing this, if I multiply out this side to that side, then I get the following. I get cosine of whatever I multiplied out with. So it's going to be cos theta and then p minus r q minus r is equal to what? P minus r dotted with q minus r. Oh yes. Also, I should be a bit more careful here because these are all dot products with each other. Let me just not forget that dot in between. Otherwise, this doesn't make sense. Okay, remember it's a dot product between two vectors. Then we get a scalar. Okay, so now I have the most important part. Now I have this, and I have this part we were unsure of. Great. So thus, then I can say p minus q squared, we're starting here again. We're just gonna fill this in with the new information we have, is equal to p minus r. Let's just rearrange it that it looks like this. Plus with q minus r squared minus 2 times p minus r dotted with q minus r. And there we have it. That's our proof. Okay, and that's what they wanted. Question 4.2. Let A, B, C be vectors in R3 in the triangle with vertices A, B, and C. Let gamma be an element of 0 to pi. Denote the magnitude of the angle formed at the vertex C. Let gamma be greater than 0 and assume that these lengths are all equal to gamma. Use the cosine rule and determine the value of this. Okay, so again, it's a triangle, so let's draw what we have. We have vertices A, B, C. Okay, so it's A, B, C. Okay, and they tell us let gamma denote the magnitude of the angle formed at vertex C. So just for convenience sake, gamma can be written as this or this. It's just easier to write it as this. Okay, so gamma is right here. Perfect. So assume this gamma is greater than 0, and this also assume that a minus b is equal to a minus c is equal to c minus b. So they tell us that everything here is the exact same length, and everything is equal to, let me just make sure of this. I think this is supposed to be a lambda. Okay, so let's make that a lambda. Okay, in this exam, they try to confuse everyone with the signs, but yes, let's make that a lambda. So all of these sides have length lambda. Okay, use the cosine rule to determine the values of gamma. Great, so we want to calculate gamma. We first start with the side across from it, so we just say lambda squared is equal to lambda squared plus lambda squared minus 2 times these lambdas cosine of the angle, which is gamma. Okay, so gamma squared is equal to 2 gammas, or lambda squared is equal to 2 lambda squared minus 2 lambda squared cosine of gamma. Okay, remember we can't just divide by gammas or lambdas. That's not how math works. Just remember. So let's just take everything to one side to get it equal to 0. So it's just lambda squared minus 2 lambda squared cosine of gamma. Factor out a lambda squared 1 minus 2 times cosine of gamma. So now we can say, thus, lambda is equal to 0, or 1 minus 2 cosine of gamma is equal to 0. So now let's get cosine of gamma alone. This will then just be a half, okay? And then gamma would just be, okay, so it's pi over 3. I just had to make sure of my special triangles. Okay, so just remember to study special triangles. So from high school, they were just those two 60 degrees, 30 degrees, and then the 45 ones. Okay, so just know how to use them and remember in radians, so don't use degrees. Take some time, get a table for Google, and then just study that table. Just remember these angles. Make a rhyme or something. Just don't forget your special triangles or your special angles. Okay, and that was question 4. Okay, so let's read through question 5. In this question, you may assume the following properties of the norm without proof. Reference the label at each instance where you use a particular property. Okay, and then for all x and y vectors in n, and a is a scalar. Cool. So we know that the norm of a vector is always greater or equal to 0. It is 0 if we have the 0 vector inside. This property is true because it's just multiplying with a scalar vector. And then this triangle inequality. Triangle inequality. Cool. You're always going to see this. It's very important. So the following is a false statement. For all AB, in R3, they are narrowing it down a bit for us, just in R3, not in Rn. So A minus B is less than or equal to A minus B norms. So it's kind of trying to look like the triangle inequality, kinda, but obviously this is false, and they tell us this is a false statement. So give two vectors in this form, so just the last two components of both of them are 0, and show that this is false. It doesn't hold for your vectors. And they give us a hint. Try using components with different signs. Oh, wow. So whatever we choose here, the other one should just be a different sign. So it's very easy. This is a big tip. So we can just use any number, and then yes, it'll spit out for us a negative on the other side, and then boom, we can do this. So let's give two vectors. Let A be equal to, let's say, 4, 0, 0, and B be equal to minus 4, 0, 0. Now, let's compute this left-hand side. A minus B. This is equal to what? It'll just be 4, 0, 0 minus 4, 0, 0. And let's simplify this. Then you'll get 4 minus 4, which is just 8, 0, 0. Okay, now we just get the norm of this. It's square root of 8 squared plus 0 squared plus 0 squared, which is just 8. And what else? We need to show that the norm of A minus the B, what is this value? So it's just equal to the norm of 4, 0, 0 minus the norm of minus 4, 0, 0. This is square root of 4 squared plus 0 squared plus 0 squared minus 4 squared plus all the zeros. Okay, so this is just 4 minus 4, which is 0. So since a is not equal to 0, this part cannot be equal to um, this part. Oh, sorry, a minus b squared. It just doesn't work. We can actually replace this. 8 is not less than or equal to the 0. Okay, so just by counterexample, remember this is not in all general cases, this is just an example we gave. So since 8 is not less than or equal to 0, just replace that sign. This is also not less than or equal to this. Great. Okay, now 5.2, another proof. I'm going to do this in, let's do it in just normal black. Cool. So they want us to prove that for all vectors in Rn, that this is actually true, and this is the triangle inequality. Very nice. So this is from the previous one. We're basically going to have to prove this. Okay, so let's start with what's there. So what is this equal to? So let's rewrite it in the form we can actually work with. So let's say a plus with minus b, so that it looks like this, so it has a plus sign in the middle. That's the important part. If you get that, you're fine. Okay, so just change it so that there is actually a plus, so that we can use the triangle inequality. Otherwise we can't. So now we can say, okay, this is less than or equal to a plus with minus b. I think, no, this is not squared. So this is directly from D. So from D. Okay. And now we have this is equal to A. We didn't change that. Now we can say plus minus absolute of B. Why can we say this? We're using C. So from C. And what is the absolute sign of a negative 1? Okay, it's just 1. So that's what we have. So let's go back in our signs. Let's read, is there anything else in a equal to? Yes. There we have our sign that's important. So A minus B is less than or equal to whatever is here at the bottom. Great. Plus B. Yep. Cool. So that's the proof for that one. You can see this goes directly to this as required. Great. Now, next question. Question 5.3. Again, this is another one that's not as intuitive. So you kind of have to manipulate a few stuff to get to the answer. Unfortunately, in every test, there is a question like this. That's not easy to see. And in a test, most people usually panic because they see this question. Just stay calm, just read what they give you. Hints are usually very important to read. So yes, let's just go slowly through this one. So let v, w, and x be vectors in Rn, and let epsilon be greater than 0. Okay, so it's just a positive number. And assume the following. Assume that our norm is now less than the epsilon. And remember, epsilon is a positive thing, and that's fine. That's right to assume, because remember, the norm is greater or equal to 0. Now they tell us it's less than a positive number, and w minus x is less than a positive number, and x alone is less than a positive number. And obviously it is still greater than or equal to 0. That's still true for all of these. So under these assumptions, show that v minus 5x is less than 6 epsilon. Okay, and a hint, start with this, add and subtract the scalar multiple of w and apply d to obtain a term that looks like the left of 1. Okay, the rest is up to you. Okay, so they tell us to start with this. So don't directly go start with this, because that's not entirely helpful. Start with this part and then work yourself to this part. Okay, so start by saying the norm of v minus 5 of x. Okay, and now comes the part where you have to like kind of manipulate a bit. So remember, what can we use? We can use something with this v minus 4w. Okay, so let's introduce what we don't have yet. We have at least a v, but we don't have this 4w yet. So let's go introduce it. We can say v minus 4w plus 4w minus 5x. So I've changed nothing, I just added 0. Okay, and then now for this we can use the triangle inequality, or part D from the previous statements. Okay, to split this up, because there's a plus sign in between, which is amazing. So now we can have this. Oh, remember, it's greater or less than 4w plus 4w minus 5x. Okay, so we kind of have to get rid of something, or we have to change something, or yeah, we want to use another property somewhere else. So we can kind of see we have a w and an x alone. So if we can get a w and an x from this is already fine. Why do I say this? Because it's right there. Okay, this is already fine. So let's not look at this part, let's look at this part. Let's try to get it in this form. Okay, so the only thing I can think of is to change something again. Okay, let's change this 5 to a 4x minus x. Okay, oh yes, remember here we used part D, the triangle inequality, to actually get this out. Okay, so now if I have this, remember this part is still great. We don't have to change it, but this part now. Now we have something minus this part we kind of added. So let's use what we did here. Here, something minus something is less than this. Basically, the triangle inequality just with the negative sign. So let's use that property. So 4w minus 4x plus the norm of x. So this is from 5.2. We use that property now. Okay, and now we can kind of see we can take out the 4's. So v minus 4w plus with the 4 in absolute signs. Please don't forget it at first, because you're using a property, and properties need to be exact. So this is from, I think, C. It's from C. And now I have this, all of this. So now I have a 4 here in front. I have this that's given. Let's go highlight in different colors. So this part is given right over here. This part is given right over here. Oh, I just have to fix that. I don't know what I did there. I've just erased the 4. And then let's do orange. This part is here. So I used everything. Great. So now I can just say, okay, well, this will be less than, not less than or equal to, less than, okay, less than epsilon plus 4 epsilon plus epsilon, which is equal to 6 epsilon. Okay, so now let's go back in our signs, look for important one. This one has more gravity to it. So stop here. Thus, v minus 5x is less than 6 epsilon. Okay, do it like that rather. Nice. So that's our answer for 5.3. 6.1. Write down the definition of what it means for a point to be between two other points. Be sure to define all symbols. Okay, so if you think about this, if you have 2 points, let's call it A and B, then C is somewhere in between. Somewhere. Okay, so now let's just write this neatly in mathematical form. Okay, so let A, B, C be elements in R3. This is important. Okay, then C is between A and B if there exists some t from 0 to 1. This is also important, between 0 and 1, such that C is equal to AT plus A minus B. Sorry, I don't think the T is supposed to be there. Okay, so this is basically a line, the formula of a line. And then if your T is between 0 and 1, then C would be between A and B. Just a small correction, for a line, it's this. Okay, so it's then basically the end point, the terminal point minus the origin point. Okay, if you want to think about it like that. So it's A plus with B minus A. Cool. Continue to the next one, 6.2. Okay, so 6.2 is the last question. And it's also a little bit of a difficult one. The last few questions are always a little bit more proof based and a bit more engaging than the first few. So let's read what they say. So they say P, Q, and R are elements of R3. Be points so that P, Q, R are not all in the same line. They're not in the same line L. Let X be any point between P and Q. So let's just write a note here that X is between P, Q, so that we don't forget it. X somewhere. So it's between them. Define the line L as this. So it contains X and R, as we can see. And the plane P has P, Q, and R in it, which is very nice. So by direct computation, show that, as I said, L, well, that set L is contained in set P, and they give us this hint. Okay, so let's start. They tell us at the start that X is between P and Q, so that's a good starting point. Okay, so there exists some, let's say, S. Okay, I work with S because they work with P and Q. X is between P and Q, and P and Q are both in this plane formula. P and Q is not here. Okay, so that's going to make the computation a bit more difficult. So let's say there's some S, because the plane works with S and with T, so it's completely fine. There is just some S element of 0, 1, such that X is equal to what? So it is Q plus with T, P minus Q. That's what it means for something to be in between P and Q. Okay, so now we have that. And now we can actually use the hint. Okay, there are a few parts to this. So now this is the hint part. Let me just write. This is the definition part. Now we're going to use the hint part. Okay, so X is then equal to, what is Q? Q is given as this. Okay, and let's put it into this. Okay, sorry. So now, in place of this Q, I'm just going to say, okay, it's R plus Q minus R plus T, and now it's the P part. We know what P is as well from the hint. P is R plus P minus R minus the Q part again, which is just minus R minus Q minus R. Let's just simplify all of this. This is then R plus Q minus R plus with, these two are going to cancel out, so we don't even have to write them, plus with T P minus R minus T Q minus R. Okay, so let's go see what happens here. Here we have a Q minus R, here we have a Q minus R. Okay, keep going to the next slide, sorry. So I think let's go group them. We keep the R here. We also say that we take out a Q minus R, then it will be 1 minus T plus T P minus R. Okay, so next, okay, so now let's go use the line information. The line. So let all y be element of L. Okay, so now we can just literally give it a name. And there exists some T or S. Let's see what we're going to call it. Well, we use T here, so let's go use S on the other side. Okay, so for some S is an element of R, then we can just like literally rewrite the line equation, which is just R plus S, X minus R, but we just calculated X. We know what it is. I just erased the X. Okay, so now let's go substitute that in. So that'll be R plus with S. Again, in the brackets, will be this minus r. So this minus the r, so the r's will just cancel out immediately. Then we will just have t p minus r plus 1 minus t q minus r. I just rearranged everything in there. Okay, so this will give us r plus st p minus r plus with s 1 minus t q minus r. Okay, but just remember s is an element of r and t is an element of r. Okay, so this, just gonna underline, is an element of r, and this is an element of r. So what can we say? This is then just literally a plane again. So r is equal to some, let's call it anything, let's say k. P minus r plus k, q minus r, for k is an element of r. Okay, so now this looks awfully similar to this. Okay, so we plugged in the line formula, but we got out the what? We got out the plane formula. So yeah, now we can say y is indeed an element of the plane. We just proved y is an element of the plane. And now my conclusion, thus, I'm just going to write my conclusion over here. Thus, L is contained within the set P. And this concludes all the questions for the semester test.